Dear students, today we are going to discuss the linear programming, why we use this linear programming in the performance management subject. If we start from a question that let's suppose I have to produce two different products. Now the question arises, there is always limitation of the resources. Question arises, how much should I produce product 1 and product 2? How much should I produce each of these products that can maximize my profit? Okay, so if we try to understand this question, it is going to help us that we have two different products to produce, and we have the limited resources. Within the given limited resources, which product should I produce more in number, and what will be my profit? So this is the today agenda. Let me show you some slides to revise it, and then I'm going to solve one question for you people. So this is the linear programming. Actually, the purpose is to optimize the use of the resources in a very good way, allocating the resources, and we can improve our decision making. Decision making is that which product should we produce in which numbers, and the purpose is to maximize the profit. Or maybe sometimes the purpose is to minimize the cost. It actually improves the operational effectiveness under the given constraints. Constraints, the given constraints, which product is going to give me more profit. So I'm going to start from the example. Let's suppose we have two different products. The one product is X, and I named another product Y. Now the objective function, the purpose of this equation is that I want to maximize my profit or maximize the contribution. So if I am supposed to produce the two product, I need to calculate that how much L should I produce and how much M should I produce. Or like in this example, we can say X and Y. 4 means that 1 unit of X, let me make it X, and this one let me make it Y. So each unit of the X is giving me the 4 contribution. What do you mean by contribution? By contribution, if you remember, we mean that sale minus variable cost. This is equal to contribution margin. So this is not a net profit. Fixed cost is not yet deducted. Only variable cost is deducted. So like in the first case, the contribution margin for product X is 4 per unit, while the contribution margin for Y is 8 per unit. Now the question arises that how much should I produce and how much Y should I produce to get the maximum profit. Now my dear, we have three different departments: cutting department, stitching department, and assembling department. Let's assume that to produce 1 unit of the X, the cutting department require 8 hours, and to produce the Y, cutting department requires 10 hours. The maximum number of hours I have is the 11,000 hours. So my constraint is that I am supposed to produce the X and Y combination within the given 11,000 hours. Stitching department takes 4 hours to produce 1 unit of X, and it takes 10 hours to produce 1 unit of Y. The total hours available in the stitching department is 9,000. Similarly, the last one is the assembling department. It takes 12 hours to produce X and 6 hours to produce Y. The total number of hours available are 12,000. So these are the my dear constraints given, and this is my objective to achieve the maximum profit. The question arises, how much should X and Y should I produce? While using the linear programming, okay, one thing you need to understand is that we use the graph. On the graph we have x-axis and y-axis, so that's why we assume here that we are only going to produce the two products. So let's start and solve this question. What is my objective? The objective is to maximize the profit x and y. Contribution for 1 unit of x is 4 and y is 8. This is the contribution of each unit. What are the constraints? Constraints are, I have three departments. This is the cutting department, cutting department require 8 hours to produce 1x, and it requires 10 hours to produce y, and total number of hours I have is the 11,000. Similarly, the stitching department, let me first put the data. It requires 4 hours to produce 1x and 10 hours to produce 1y. The total number of hours are 9,000. Assembling department requires 12 hours to produce 1x and 6 hours to produce 1y, and the total number of hours are 12,000. Now let's, my dear, first use the graph. Which of the within the given constraints, how much x and y should I produce? This is the question. So let's start from the first. Let's try to learn it. How can graph help us? Let's check the maximum x. How much x can I produce? Let's suppose I produce nothing in y. Let's suppose if y is equal to 0, how much x can I produce in the cutting department? On the other hand, let me check that how much y, maximum y could I produce if I do not produce any unit of the x. Okay, so got the point. Let me first check that in cutting department, how much x can I produce if I don't produce any unit of the y. Similarly, what could maximum in y I produce if x is equal to 0? Let's first find out the maximum number of units which I can produce. Let's suppose if I'm producing y 0, now how much x I can produce? You can see that in cutting department I have total 11,000 hours. I'm not producing any unit of the y. So how much x can I produce? 11,000 divided by 8 hours. So the maximum number of x which I can produce is 1,375 units if I'm not producing any single y. Okay. Now on the other hand, if I produce only y, suppose the x is 0, how much y can I produce in the cutting department? The maximum capacity I have 11,000 hours and one unit take 10 hours. So the maximum y I can produce is 11,000 hours. Now let's suppose make the graph of the only cutting department. How much number of units can I produce? Let me make a graph here. This is my cutting department. On x-axis, I'm considering this, and on y-axis, considering this. And now you can see that in cutting department, if I want to produce the 0 of the x, how much y can I produce? It's 1100. Similarly, if I'm producing 0 unit of the y, maximum x I can produce is the 1375. So this is my constants. I cannot produce this combination. Like for example, this combination means that 800 of the y and 600 of the x. Reason is that for this I need more number of hours. So I cannot go beyond this line. I can be in this within these constraints. Like for example, I can produce 800 of the y and 200 of the x. I can produce this much, but this will be not the optimal use of the number of hours of the cutting department. Okay, it will consume less hours that is available to me. Like for example, if I produce 800 of the y, it means that one unit take 10 hours. So 800 multiplied by 10 is the 8,000. And if I produce the 200 of the x, so it takes 8 hours. So 200 multiplied by 8, 1600. 1600 plus 8,000 means that if I produce this combination, I will be only utilizing 9,600 hours. So this is the best combination. Okay, you can produce this much. You can produce on this line. So this is the maximum which we can produce with a given constants, but I cannot go beyond this line. Now let's check the capacity of the stitching department. Let me copy it here. So the stitching department, stitching department. If I produce 0 units of the y, how much x maximum can I produce? Total I have 9,000 hours and one unit take 4 hours. So maximum I can produce the 2,250 units of x if I don't produce anything of the y. You can see y is 0 here. Now let's suppose that maximum y I can produce is 9,000 total hours and one unit take 10 hours. So I can produce 900 maximum of the y if my x is equal to 0. Let's draw the constraint line again here on this table on one graph. It will help us to understand it. So let me do it on one graph. Let me add another one. Now this time my x is this one and y is. And now you can see that the second line show that orange line show. Let me if I can change the color. That may be easily visible. Yes, now it's visible. Okay, the orange line actually show that the stitching department constraints. You can see while producing the 0 of the x, I can produce 900y, the maximum. And if I'm producing 0 of the x, I can produce the 2250 of the x units. Again, my dear, no, if I'm only using this two department, if at the moment, let me ignore the third one. Suppose I have this two department, cutting and stitching only. Okay. Now this is my dear constraints that look, you can see that I can produce this combination by using the two department because I am inside the constraint line, but I cannot cross this line. Okay. So I am supposed to be within this constraints. I cannot even produce in between this because for this I need more number of hours of the stitching department. For example, if I want to produce 1000 of the y, let's suppose this much of the x, I cannot do it because the stitching department stopped me. There are constraints. Similarly, you can see that if I want to produce this combination, I cannot produce because for this combination I have enough hours in the stitching department, but I don't have the enough hours in the cutting department. Now my constraint is like this one. This line is the maximum point, and this is the another one. This is the maximum. The rest you can produce in between this. If you are producing in between this, it means that you are not utilizing the all hours. Utilize all the hours, either you should be on this point, or this point, or maybe this point. Then this on this line, okay? This line and then the orange line. But no doubt we have the third department also. Let's draw the constraint of the third department also. Let me to save some time, copy it directly. Now assembly department. If I produce nothing in y, maximum x I can produce is I have 12,000 hours, and for 1 unit it requires 12 hours. So maximum I can produce 1000 unit of the x if I produce nothing in y. Similarly, if I produce 0 unit of the x, the maximum y I can produce is 2000 units. Okay. Now let me draw these constraints also on the same graph. This is the assembling department. Now my axis and y is okay. Now you can see the green line. Green line actually present the green line presented the assembling department. Now you can see that these are the number of hours available to produce the x and y of the assembling department. But the problem is that if I want to produce anything at this point, I cannot produce because I have the constraints of the first two department. So how much? Now what is my maximum combination? Either I should be on this point. Okay, this point means that 900 of the y and 0 of the x. Either I should be on this point, second option, and this is my third option, the maximum, and this is my fourth option. I cannot go for this one, this combination, because for this I need more of the assembling hours. So now within this graph, this is the my dear area in which I can produce the maximum number of units. Okay, so I have made the slides for you people that will help you. These are the constraints, how much y I can produce if x is equal to 0. Okay. Now this is my dear the same graph which I uh, make there in the Excel. I'm actually giving the name. This is the P1 maximum bit combination, and this is the Q, and this is the R, and then this one is the S. Now, my dear, we have one of the technique is that we can use the trial basis. We can check that if this combination is giving me more profit, or this combination is giving more profit, and third or the fourth one. Okay. The second option is that the more you are far from this origin, the more it is a best option. Like now, if I can make an estimate, so it seems that Q is the most like suitable one. Let's check it. On number P, let's check it on a trial basis. Let's check on the trial basis. So we have different combination. Let's suppose P. P, if you see into the graph on this the PPT slides, so this is actually I name it P. On P, you can see that X is 0 and Y is how much? Y is 900. X and Y, and let's check the profit. X can give me the maximum for 1 unit of X, how much profit or contribution I have? 4. 4. And Y can give me 1 unit of Y can give me contribution per unit of Y is 8. Now let's check it if I'm on the point P. It means that if I produce nothing in X, but I produce 900 of the Y, what will be my total profit? You see the equation of the profit is that is my objective. Objective is yes. That is my maximum contribution. 4x multiplied by 8y. If I produce 0 unit of the x, so mean and unit give me 4. In this case, there is no contribution from the x because we are producing 0 unit of the x, and I'm producing 900 of the y, and 1 unit is giving me 800. So means that if I go for this combination for P, my profit will be 7,200. Okay. Let's suppose I go for the second option, that is the Q. In Q, I can see that my X is 500 and my Y is, you can see that somewhere 700. Okay. If you have the graph paper, like on graph paper, it's very easily visible. It is actually 700. So on point Q, X is 500 and Y is 700. So if I produce 500 of the X and 1 unit is giving me 4, so I can earn from X and from Y. I can produce this 700 units. This is the maximum combination, one of the option. Okay, now you can see that instead of going on the option P, within the given limit, you can see within the given limit of all of the department, if I produce 900 of the Y and 0 of the X, I can earn the 700 to 7,200 profit. Here it seems that Q is better than the P. Let's check the R. On R, if you see that we have 750 of the X and 400 the y. 400 of the y, 700 of the x. Okay. So now again, even I can now drag the 700 on x multiply by contribution per unit is 4 plus 400 of the y per unit contribution is 8. Okay, so far p q both are better than the r. So far this is on the first priority. This one is so far on second, and this one is so far third. This combination. Let's check the s. On s it means that we produce nothing of the y and we produce 1000 of the 1000 of the x. I produce 1000 of the x and nothing in y. If I go for this combination, what will be my profit? 4000 from x, nothing from y, because I'm not producing any unit of the y. Okay, so this is the worst combination. Okay, so my dear, from graphical presentation we come to know that this is the good combination. If you want to earn a maximum profit within the given constraints of all the three departments, and you can see that this is the combination. Let me, it's more visible. So this is the best combination, but still you can see that we are wasting some of the number of hours of the last department, which is assembling department. This area is actually called a slack. In accounting we call it slack. This is the wasted number of hours. To utilize this area, the slack area, what we need to do, we need to add some resources into the cutting department and the stitching department. But before adding it, we need to check it. Either adding any of the resources in the first department and second department, will it benefit us or not? For that, my dear, we calculate the shadow price. For example, if I want to add 1 hour of the cutting department, how much will it how much it will benefit me? If it is good for me, let's suppose the additional hour, if I'm adding it let's suppose cost me $4, but the additional benefit by adding 1 hour, maybe the additional benefit is only $3. So then there is no need to add the additional hour. Okay, so for that we need to understand the meaning of the slack. Slack means that the number of hours left in one of the department. In this case, the assembling department have still number of hours which are not utilized. So my dear, this is the one way to find out the best combination using the graph. Now let's suppose use this simultaneous equation. Okay, let me save some time. We have three equations here. Okay, but if you can see from graph, this was the best combination. Okay, now let's check it through the equation. On this, my dear, sorry, this combination you can see that two different department line there is intersection of the two different department. One is the cutting department and one is the stitching department. So we need to look into this two equation, which will help us to calculate the good or maximum combination while utilizing the all of the constraints equally. So my dear, now you can see that there is one of the method that we deduct equation 1 from the 2. Okay, we can see that if we deduct it, so if I want to deduct the equation 2, if I want to find the y, I can multiply the second equation by 2, where I will get the result of the at x and at x, and if I deduct it, I can get the value of y. But luckily we already have the same y, so I can do without multiplying anything. I can right here to the I can subtract equation 2 and subtract equation 2 from equation 1. And if you deduct it, you will get that 8 minus 4 is equal to 4x, 10y minus 10y is equal to 0y, so no need to write y. 11,000 minus 9,000 is equal to 2,000. This implies that x is equal to 2,000 is multiplied and it will get on another side, it will be divided, so x is 500. So it shows that if I produce the 500 of the x, now you can see that while on the graph also when we use this combination q, you can see that it shows us to produce the 500 of the x. Okay, now let's find out the y. Now we already have the value of the x. You can put the value into any of this equation. Let's suppose if I put this into the equation 1 to find out the y. Now I have the value of the x, and that is 500. Y is not known to me, and 11,000. So 8 multiplied by 5, 4,000, plus 10y is equal to 11,000. Now this 4,000 when come on this side, it will be minus. So 10y is equal to 11,000 minus 4,000, which is equal to 7,000. 10y is equal to 7,000. We can find the y, and y is 7,000 divided by 10. It will multiply, and if it come on this side, it will be, the answer is 700 units. Okay, so the best combination is that x is equal to 500 and y is equal to 700. You can find out through the equation also. Okay, similarly, if you can see that through the graph also we get the same answer, 5 and 7. This is actually a combination of the q, the best combination. You can even check this one also. You can see that here there is the green line and the blue line. Okay, instead of putting here the green line present the department, the stitching, and the blue line present the cutting department. Yes, you can even replace. You can do the same. You can get the same solution by replacing this equation by the third one. Again, you will get the best. You will get the combination of the 700 on fx and 400 of the y. I think there's no need to do it again. Okay, we already know that this one is the best combination. Got it, my dear? So you can see that I have sold it and the maximum profit is 7,600. This is the combination of Q. Now, my dear, as I told you that you can see from the graph that it is the best combination, but we are still wasting some of the number of hours. And that is in department, assembling department, the last one. I cannot go beyond this two line because the reason is that I have enough hours in the third department, but I don't have the enough department into the first two. So can you calculate now the question arises that what is the slack? How much number of hours I'm wasting? How much number of hours still I have this department? That is the okay. So this is the combination of the assembling department. Let me take help from this one. Assembling department. This is my equation. Third, how many number of hours required? 12 hours required for X and 6 hours required for Y, and total number of hours I have is the 12,000. Okay, my dear, as the solution suggests me that you need to produce the 500 of the X and Y 700. Now let's check that if I'm producing the 500 of the X and 700 of the Y, how much number of hours it will require in the assembly department. Now let's check it. 12 hours required for one X and I'm producing the 500 of the X. How much number of hours required for 1 unit of Y? 6 hours and I'm producing 700 of the Y. Let's check it that how much number of hours it needs. It's actually consuming. So I can see that 12 into 500 means 6,000. Okay, you can see that. There is calculator. Yes. 12 multiplied by 500. 6,000 hours required for X plus how many hours required for Y? 6 multiplied by 700. 4,200. So the final answer is that it needs 10,200. If I add this both, so for this combination of X and Y, I need only 10,200 hours in the assembly department. You can calculate the now slack value. How many number of hours are available? 12,000 hours are available. And how much I will be consuming? If I produce this combination of the X and Y, it means that I'm going to waste 10,800 hours. So 1,800 hours, that's why I check it. I'm wasting 1,800 hours. Okay, this is actually my slack value. The number of hours or the number of resources. It may be number of hours, it may be raw material. Okay, so I cannot produce this combination because the other two department is restricting me. So this number of hours, which is 1800, it is now wasted. Now let's think about this, that should we go for the additional number of constraints of the x and y? And one thing more, that there is one of the word used called binding. The word binding is used that when your constraints are fully utilized. So in this example, the cutting and stitching department, these are the my dear binding department where we are utilizing our resources fully, while the third one, assembling department, is slack, means that where full hours are not utilized. Okay, the question arises, should we go for the additional resources in the binding department, which may help us to utilize the slack? So that is known as shadow price. The accountant can give you the information that how much, if it is going to benefit us while utilizing more resources of the binding department, how much should additional cost which we can bear. Okay, so we need to calculate the shadow price, which will help us. Suppose the shadow price is $5. It means that if I'm utilizing additional number of hours, let's suppose in the cutting department, it is going to give me the $5 benefit. But let's suppose my cost is, let's suppose $6. It means that I'm going to lose the $1. So then I should not go for the more production or more utilizing of the uh, cutting department, which is the 11,000 hours. So let's check it. How can we check it? So the same, only you need to do one thing, is that there are three steps to calculate the shadow price. The first step is that solve the equation again by adding one unit, in this case 1 hours, to get the revised number of units. Okay, what do I mean by this step? Like for example, let me check it into the, this was my, well, let me name it, suppose equation 3. What I'm going to do is that first step is, let's add one number of hours more. Let's add one number of hours more and then check that how much it is going to benefit me additionally. So instead of the 11,000 hour, I'm going to add one unit more of the constraints. Okay, you can do here also, but let's check into the cutting department. This is the first step. The second step is that calculate the revised contribution. Means that solve again this question. Now this time when you will be solving the question, it will be like this. Instead of the 11,000, it will be the 11,001. Okay, it will be the 11,001. Now again you can subtract the equation 2 from 3. So this is the second step. Calculate, first add one unit of the source, one of the constant or the binding department where you have fully utilized the resources. The second one is to calculate the again revised contribution. And the third one is that is actually shadow price. Once you get the value from the revised contribution, minus it from the original contribution, which was the previous one. In previous one, the combination was 500x and 700y. Let's check it. Now you can see that if you subtract the equation 2 from equation 3, now this is actually equation 3. So again, if it's subtracted, ny will be finished, and you will be left with the 4x is equal to 11,001. Now if you calculate the x, your x is 11,001 divided by 4. It is 2,750. Is 2,750.25. What was the old combination? You can see that when it was here, I think this is done. Now let's find the put the value in any one of this equation, either the third one or the fourth one. Put the value of the x. Value of the x is 50.25. Y we need to find. What will be the answer of the y? I have already solved here, so let me make it quickly. You can see that I have added 1. Okay, here I name it equation 1, then 2. Okay, then we deduct it. Sorry, I didn't deduct it here. Okay, sorry, I didn't deduct it here. Let me do it again. 8x minus 4x is equal to 4x. 11,001 minus 9,000 is 2,001. That's why I was a bit surprised that the value is very different. It is 2,001 divided by 4 is 500.25. Sorry, 500.25. If x is 500.25, hopefully you don't get confused. Actually, I didn't deduct this 11,000 from the 9,000. I have written here, but I didn't did it mistakenly. So now you can calculate the y. Y is 699.9. You can calculate it the same like we did it earlier. So what we did, the first step was to add one unit in the resources, the constrained resources. We try the cutting one, and then my dear we calculate the combination. The best combination over here, it shows that x should be produced in 500.25 units and y should be produced in 699. Let's calculate the contribution, the maximum profit if I produce this combination. In 1 unit, what is the objective? Remember, 4x plus 8y. Okay, if you remember it, contribution of the y is 4 and the x is 4 and y is 8 per unit. Now if I produce 500.25 of the x and then I produce 699.9 of the y. What will be the my distribution? Where is the calculator? 4 multiplied by 500.25, 2001, plus h multiplied by 699.9, 5000, 5,599.2. So this one plus 2001 plus 7,600.2. This is the answer. Okay. Now let's check the steps. First step was to add one unit to the given the resources and then calculate the revised contribution. Okay, which is in this case 7,600.2. Now the shadow price is, let me directly copy from here. The formula for shadow price is, if you check the third step, the revised contribution, which is 7,600.2, and the original contribution was 7,600. If you remember, we did it in the, I have already done this. Okay, in the previous one we check it. This was the 7,600. Okay, we did in the Excel, yes, this one. So now the shadow price is 0.2. It means that if I add 1 unit of number of hours into the cutting department, is going to the additional number of hours is going to give me the 20 cents. Now, my dear, you need to, should you go for this additional hour or not? You need to do the comparison. What is the cost of this additional number of hours? What is the cost of additional hour of cutting department? In this question, I don't have the value for the cost of the additional number of hours, but we can compare it. Now, if the cost is less than this shadow price, then we can add it. But if the cost is more than this additional benefit or the shadow price, then we should not go for the additional resources and we should wait and we should stay on this combination, which is U. Hopefully you get this idea. And if you try to read it, there's a company, ABC Limited, it produces the fresh juices. In summer, let's suppose it produces the two fresh juices, banana juice and strawberry juice. The maximum demand for banana juice is, no, the question is solved, the previous one. I'm just going to teach you the interpretation which is going to help you in the exam. You will be getting maybe the two number from this slide. You can see that the maximum demand for the banana is 20,000 units and strawberry is, let's suppose, 35,000 units. Currently, the company has three limiting factors: the sugar, labor, and no normal sugar prices. You can see $20 per kilogram, and the labor which is paid is the $10 per hour. The company has used a linear programming approach to calculate the optimal production plan. We have used the linear programming, which give us the result of how much should I produce the banana juice and strawberry juice within this given limitation. Accountant has calculated the shadow price of the sugar and labor as 10 per kilogram and 5. Why the shadow price of pulp is 0? Why pulp is 0? Because in pulp it shows that when the shadow price of the product is 0, it means that there is no need to add any additional unit, or we can say that this is the slack department in which we already have the additional hours. Like in our case, the assembly department have the shadow price equal to 0 because we don't need to add any additional number of hours. But in this case, you can see that the shadow price in this example, the shadow price of the sugar is 10 per kg, 10 per kilogram, and its cost per kilogram is $20. It's given in this exercise. Their cost is the 20 per kilogram, while the shadow price is 10. The additional is 10. Similarly, the labor are charged 10 per hour. Its shadow cost is per hour is 5. This is for sugar, and for labor, the shadow price is $5 per hour and 5 per hour, and the cost of labor is 10 per hour. Okay. This is the my dear shadow price, the additional price of the one. If I'm going to add 1 kilo more into the sugar, because these are the binding department, and the third one, the pulp, is the slack department. Okay, because there we have some extra number of hours. How can I know? Because the shadow price is 0. Now my dear, it means that how much additional is 20 plus 10. Now try to learn the interpretation of this. This is going to help you in the examination. It means that a company can pay maximum rate of $15 per hour. Why $15? You can see that 5 is the additional benefit and 10 is the my dear the cost. So 5 plus 10, 15, you can afford it. Okay, so I told you that shadow price show you the additional cost of the additional unit if you are adding it. Here, what is the additional one? It is the 20 plus the additional 30 kilogram. You can afford the additional 1 kilogram of the sugar if it is costing you, like you can read, a company can pay a maximum price of 30 per kilogram to purchase 1 extra kilogram of sugar. Okay, so in pulp the shadow price is 0. It means that there is a slack of the pulp resources. So you may be receiving such kind of the MCQs in a paper. They may give you the like the data will be given, and they may ask you to interpret it. Maybe you'll be having A, B, C, D options, and one of the interpretation will be true, the rest may be the false. Hopefully you get it. This was about today lecture. Thank you so much.